Hi there, I thought I would tape a video on how to simplify radicals. So, simplifying radicals, we've done a little bit of it in class, but then there's a few of you that still are struggling with it. So, I have a quantity under the radical, and I need to see, this is taking the square root, so I need to see, take out numbers or factors that are perfect squares. So, you can do it a couple of different ways. The first way you can do it is you can actually do a factor tree and take it all the way down to its complete factorization, and then go from there. So 5 goes into that 15 times, and then we have 5 and 3. So when you do it this way, you can see, hey, I have a pair of 2's. So if I have a pair of 2's, a pair of 5's, excuse me, that's going to be the square root of 25. And the square root of 25 is going to be 5. So anything I have a pair of, I'm going to put outside the radical. And if I have more than one pair, I just multiply those two numbers together. But in this case, I only have one pair, so I put a 5. And then on the inside of the radical, I'm left with a 2 times 3. So my answer, simplified, would be 5 times the square root of 6. Number 2 is a little bit different. Well, it's the same, but I think there might be a couple of pairs that we can bring out. So 54, and I know that I have the number 9, and I have the number 6. Yes, 9 times 6 is 54. And then 3, and 3, and then 2, and 3. So again, I made a mistake. I have only one pair of 3's, so I take that outside the radical. And on the inside, I have 2 times 3, and so that is 3 square root of 6. Now, I could have taken this a different way, and I could have said, okay, the factors of 54 are 9 and 6. And so I know that the square root of 9 is 3, and then I'm left with 6 that doesn't have any other squares in it. So, and then looking at 128, doing it the way I just did it, so I have 128. I have 2 and 64. So at this point, I can see, hey, 64 is a perfect square. It's 8 and 8. So I can have 8 on the outside of the parentheses, and I'm left with 2 under the radical. Moving along to different problems, we have problems like number 9, and this is where I'm multiplying two radicals together. Now, when I'm doing this, I know I can only multiply like the integers together. It's kind of like coefficients. If maybe this was 2x times 4y. Where x is going to be the square root of 10 and y is going to be the square root of 5. So in this case, I just multiply my coefficients. So 2 times 4 is 8, so I multiply my integers together. But instead of it being like this, I can actually multiply whatever is under my radical. So I have 2 times 5, so that's going to equal 8 times square root of 50. And at this point, I can see if 50 has any squares, and I have 25 and 2. And I know that the square root of 25 is 5, so I have 8 times 5, and I'm left with a 2 under the radical. So that's going to be 40 times the square root of 2. And so the things you need to remember is you multiply the two integers on the outside, and then you can multiply the numbers under the radical. So in this case on number 10, there is actually a coefficient of 1 in front of that square root of 5. So negative 3 times 1 is negative 3. And then I multiply 10 times 5, which is 50. So again, the square root of 50 is going to be 2 times the square root of 5. So I have negative 3 times 2, square root of 5. So negative 6 times the square root of 5. Moving on along to a different type of problem, we have problems like that are division problems with radicals. And we learned today in class, or yesterday in class, that you cannot have a radical in the denominator. And so, to get rid of the radical in the denominator, I can multiply both the numerator and the denominator by whatever is in the denominator, so the square root of 2. And then if I multiply the denominator by it, I also have to multiply the numerator by it, the same thing. Because really this is like multiplying this fraction by 1, so I've not changed it. So when I multiply, I have 3 times the square root of 2, and then I can multiply my two numbers under the radical, which is the square root of 4. And the whole point of multiplying by radical 2 was so that this would be a whole number, so the radical 4 is 2, and then I still have 3 times the square root of 2. And I can't simplify 3 divided by 2, so it's just 3 times the square root of 2 divided by 2. In this case over here, just keep going, I multiply again by the square root of 5, and then I multiply the numerator by the same thing to keep the fraction the same. I have the square root of 3 times the square root of 5 is radical 15, and then radical 25. So I have radical 15 over 5. The next one down at the bottom is 4 radical 3. So radical 3, 4 times radical 3, square root of 9, 4 rad 3 over 3. Now, I'm going to flip it over and see like number 14. I like number 14 on practice A because I can simplify it a little bit further. So I have 4 divided by the square root of 2, so I'm going to multiply both the numerator and the denominator by the square root of 2. So I have 4 radical 2, square root of 4, 4 radical 2, and 2. This one's different because when I get to this point, I can take 4 and divide it by 2. And 4 divided by 2 is 2, and I'm left with the square root of 2. So I'm just dividing my integers. Square root stays the same. Hopefully that'll help you be a little bit more successful with simplifying radicals.